Carrie Bennett is someone that I followed for a long time and does a really good job of making some complex topics pretty easy to understand, especially when it comes to like that quantum world. So we cover a wide range of topics here, but I think it was a great conversation. Carrie, thank you so much for taking the time to join. Followed your work for a long time. It's a really neat, pretty close-knit group in the kind of quantum space. And it's fascinating when you have just a little bit different perspective and kind of an explanation. Maybe it hits different, right? Like if Alexis describes something, or Max or you or Sarah, like there's so many different ways of kind of skinning the cat, so to speak. But if you don't care, give us that brief intro into how you got into being aware that quantum biology and circadian cycles matter.
Well, thanks for having me, Logan. And yeah, it's not something I woke up as a kid and thought, oh my goodness, I want to do this when I grow up. It was pretty much out of necessity because of the fact that I was starting to struggle with my own health challenges after my first son was born, which is now 13 years ago. And none of the traditional stuff, the exercise, the diet, the supplements, the, functional paradigm, which I thought was cutting edge at the time. I was like, oh, look, I'm doing all these functional labs and taking all these really great supplements. Of course, I'm doing the best I can for my health. And it just wasn't moving the needle at all. I mean, I'm saying maybe a tiny bit. It just wasn't enough. And then people were like, well, you're a mom now, so this is just kind of how it's going to be from here on out. You're going to be tired and you're going to complain about your digestion or your metabolism or your sleep. And to me, that was BS. I didn't want to buy into it. And so I thought I had to be missing something so fundamental about human health and how the body optimizes itself. And that's when I found the concept of light and circadian rhythm. And this idea that humans have evolved under a exposure of varying light during the day and a period of darkness, repeated over and over again for millennia. And now all of a sudden, and we've actually been able to time our bodies in certain ways with that lighting exposure. And as soon as that kind of clicked with me and I started to apply just a few strategies to quote unquote optimize my circadian rhythm, it moved the needle more in 3 days than anything I had done in years. And I was hooked and dove down every rabbit hole I possibly could just to learn more for my own health, but then for the health of my clients as well.
Yeah, the rabbit holes, that's to say the least. It's really overwhelming. With me, my little boy being diagnosed with cancer when he was 5, he's doing great now, but it was, what do you do? And you start getting all these different opinions and, when I asked the oncologist, what do I feed him, right? Like, what do we do? Like, I'm freaking out and, it doesn't matter. And it's just like, man, that just doesn't set well with me as a response. Right. And so I went first nutrition, trying to understand things. I think that's the first thing most of us gravitate towards. And as I got into that, China Study was one of the first books that really impacted me, but I didn't stop, right? And just kept learning. And so what made you get a little further away from that functional side? Because I think this is a really important transition area for us, because I had a massive transition and that was called Jack Kruse. But the functional side is so ingrained into this nutrition. So why is that not enough in those paradigms and the dogma in that kind of holding us back?
Well, I think 30 or 40 years ago, shifting nutrition would have been way more impactful than it is now. I think the environment that we're exposed to these days is toxic from the pollution perspective, more toxic from the lighting perspective, which we can go into, more toxic from the frequency perspective of non-native EMFs, that simply changing diet doesn't move the needle enough. And maybe it will temporarily, or maybe it does move it, but it doesn't resolve it completely. And that's what I saw as I just started working. I mean, I've now had the blessing of working with thousands of people, and it was like, changing diet moved the needle enough to be like, yeah, that was good, but why am I not thriving? I'm eating organic. I'm eating, nutrient dense foods. I'm finding the things that are inflammatory, and I'm still experiencing these symptoms. And so that's where it's like, there's something beyond diet that we have to really start addressing because of how drastically different our environment is, even in the past 20, 25 years, I would argue. And that timeline has a lot to do with when we started to mass produce and then sell and kind of force transition to LED bulbs and the amount of screen use that we're now having.
Yeah, that's absolutely. Before we get into the light, and I definitely want to hammer the light, is on the food side, on the food systems and the centralized aspect we're talking about, like there's so many problems, and that's part of why food doesn't move the needle now versus where it could have 40 years ago, right? Because 40 years ago the food would have been much more not exactly local and much more seasonal. It wasn't centralized and distributed across the world like it is now, right? So that's one thing. There also wasn't glyphosate. Stephanie Seneff, she's been on multiple times discussing the role that's had. The industrial model just zapping our minerals, right? Our nutrients from the soil. I think all of that plays such a key role into also why food doesn't move the needle, because we don't have a nutrient dense food option for probably 95% of the world. So can you go into a little bit on how you guide at least some recommendations around food for your clients?
Well, sure. I mean, I think number one, it's really important for people to start to go to farmers markets. Even the smallest little communities, there's one within a driving distance. And when you start to engage with small local farms, you begin to realize that there's a lot of farmers there that quote unquote get it. They're using regenerative farming practices. They might not be quote unquote officially organically certified because that costs a ton of money. It's a lot of, regulation and paperwork, but they are using the best growing practices for their plants. Or if they're raising, animals, they're using phenomenal practices for raising livestock. Unfortunately, I've seen a lot of these small farms. I'm thinking of one in particular that's just a few miles south of here that the USDA has been coming down on harder and harder. So it's harder for these small farms to be sustainable because, they're actually taking good care of their animals. But this one thing that we can do then to help them is we can say, okay, who are the farms that are raising the produce in a way that I can maybe get a CSA box where, every week I'm given a local sampling of organic produce, that now it's kind of forcing me to expand my culinary skills to say, okay, what do I do with a turnip, a parsnip, this type of squash, for example? And so then you're also guaranteed that food's been grown in your local light environment. So you're getting the seasonal component when it comes to the light signaling that gets released when we eat the food, that comes with the amount of deuterium, which is a type of hydrogen that's in the food that, I don't know if we're going to go into that today or not, but that is a quality that we can talk about when it comes to why seasonal and local is typically best. And then, I think people are always all about, what's best for the environment. And we typically go to, well, you got to eat vegan because it's not going to be great for the plants or it's not going to be great for the planet. Or, there's just some really large scale arguments that are out there that I think are failing to take into consideration that the best thing we can do for the planet, for our bodies, is to find that co-op of farms near us. And it not only benefits our health, but it also benefits our community as well.
Right. That, I want to go down that little quantum rabbit trail of why local and seasonal matters. I think that you're going to be able to do that in a really good way. But we regularly have regenerative experts on, right? Gabe Brown's on regularly, Alan Williams, Will Harris is a good buddy down at White Oak Pastures. And even just finished up just in between, our interviews, David Gumpert, who wrote the Raw Milk Revolution and laying out a lot of these food sovereignty issues with regulation stuff. And so that local matters on so many different layers. But this quantum side is a little harder to grasp, right? So how are you able to articulate that in a way that, it makes sense? Like, what in the world does a light barcode mean to somebody like that? An apple's an apple. What are you talking about? So how do you lay that out, Carrie?
Sure. I lay that out in a couple of ways. Number one, I say that our body is responding to our local light environment in terms of a 24-hour exposure to how much daytime versus darkness do we have at any given time of the year. And as we lay that out over the course of a whole entire year and we see the shifts and changes in season, our body responds accordingly. And so from the nutritional paradigm, the first way that I think I can get people to understand this is that we know that your microbiome is going to be different from the morning to the afternoon to the evening and through the night. And then seasonally, you are also going to have differences in your microbiome based on how much ultraviolet light is in your environment, which would then, what you'll see is when there's greater UV light in one's environment, that typically means that we're preparing to grow food that's going to have more fructose, more fiber, right? More of the plant-based foods. So then my microbiome shifts accordingly to be able to harvest the nutrients and break down those foods for me. And so if we eat seasonally and locally, and if we have our circadian rhythm tied to that environment as well, which we can talk about what that means. So if we're synced to our local light environment through the eyes, and we're synced to it through the foods that are growing in our environment, our gut microbiome alone is optimized to digest that food for us, which takes away a lot of gut distress. I mean, gut dysbiosis or bacterial imbalances is a huge buzzword that you hear about kind of in the functional lab community. People will do stool analyses and they'll show, imbalances, and the correction usually is, well, take this supplement or take that supplement. And I'm like, no, tell your brain what season it is. And so that your brain can communicate to your gut and your gut microbiome can adjust its population accordingly. It's a very low hanging fruit. And so then that food, once it's kind of digested and passes the microbiome, once we get the breakdown of that absorbed into our bloodstream, we send the electrons. So food ultimately breaks down into electrons, which is that too big of a jump, Logan, or can we go there?
No, Jack's been on multiple times.
So
There's
not too big of a jump. So there you go. So that's not too big of a jump for sure. So food breaks down into those electrons, and those electrons hold light. And so the light that they hold is different if it was a glucose-based source grown in the height of summer versus if it's, let's say, a fish that we caught going into winter, or if it's an animal that we killed or hunted in preparation for winter. The electrons hold different light, and the different light that those electrons hold determines where those electrons go into the mitochondrial electron transport chain. We don't have a food transport chain. We don't have a carbohydrate or a fat or a protein, right? It's electron transport chain, because the name of the game is, can your mitochondria gather electrons, funnel them through their little steps, and make water and ATP? And can they do it efficiently and to the extent that your body has adequate energy production for every organ system, regardless of the time of day? Different organs need it at different times of the day. If you can do that, then all of a sudden you have a body full of vitality, healthy energy, can clean up any damage, can really heal and be a thriving body. If you have a body that can't do that, it basically means you're setting yourself up for disease. And it might not be able to do that if the light that's embedded into the foods that we eat are causing harm to the mitochondria. And so how could the light in the food or cause harm? Well, I'll say it can cause confusion to the mitochondria, because let's say it's January 1st and I have no plants available in my local environment where I live. And all of a sudden I think to myself, January 1st, my New Year's resolution is I'm going to go on a 30-day tropical smoothie diet. Well, that is a very confusing signal, right? All of a sudden, my microbiome and my mitochondria, based on the light and the temperature, are anticipating no glucose or low glucose availability, yet all of a sudden I'm giving it high amounts of glucose. That actually generates excessive reactive oxygen species, which is damage in the mitochondria. Over time, that accumulates, and that can actually create mitochondria that become dysfunctional. Now you tie into things like what Dr. Seneff would be talking about in terms of that fruit being laden with glyphosate, and then you have a double whammy, right, to the mitochondria. But this is why, that's just one reason why I think that we want to have the local food with their light environment match what I'm experiencing seasonally. The other component of that is called deuterium. If you're cool with that we go to deuterium.
You go. Yeah, Laszlo's been on, Petra. Like, we've taken many deep dives into deuterium.
Logan, you don't need me. You've already heard this story. I love it. So with deuterium, right? We know that different foods contain different amounts of this isotope of hydrogen, or this variation of hydrogen called deuterium, and that so plants get deuterium basically because they get rainwater dropped upon them or into the soil, and they soak up the water. And this deuterium, this version of hydrogen that's found in H2O, right? We all have 2 hydrogens for every oxygen, and one of those can be, or 2 of them can be, a deuterium. So the exposure to this deuterium-rich water depends on where we're located on the planet. It's more concentrated on the equator, right? More 150, 155 ppm, and less towards the poles, where we would see something like 140, 135 ppm, meaning that the plants that grow in the tropical locations have more deuterium, and the plants that grow towards the poles, or like more towards my environment, have less deuterium. Well, why would that matter? You've already talked to Petra and Laszlo. It has the potential, if we overburden our body with deuterium, we can create another mechanism for mitochondrial dysfunction. We can essentially jam up where the mitochondria make ATP, because that deuterium is too big. It's like, I liken the way that mitochondria make ATP, where you essentially have this nanomotor called the ATPase that's spinning hydrogen through it. And it's designed to really, really efficiently revolve when you have just the version of hydrogen that we would call protium, or quote unquote regular hydrogen. All of a sudden, when you have deuterium, you have double the size. Now, hydrogen is now not only a proton, but it's a proton with a neutron stuck to it, so double the size. It's like trying to shoot into a basketball hoop, a basketball that's got 2 attached together. It's going to be very hard to do. And so that's what happens with this nanomotor of the ATPase. It just gets gummed up, it gets jammed up. And again, mitochondrial dysfunction is the result. And so if anything that disrupts mitochondria and their ability to make water and ATP, you have the potential for your tissues to begin to become energy deficient and then express disease. That's the bottom line. That's why I love studying things through the lens of quantum biology, because it really gives a common thread that we can look at so many supposedly different diseases or different symptoms or conditions and simply break it down to, does this area of the body have adequate energy? If yes, then the mitochondria are likely functioning well. If not, it's probably expressing symptoms, and it's likely due to the fact that there's something happening to impact the mitochondria and their ability to make water and ATP.
Love it. The mitochondrial aspect is so important for me with that cancer emphasis, right? And so how do we optimize the mitochondria is always just kind of a big daily focus. And so 2 things with that I have found that I think that we're probably causing a lot of problems with is actually mineral deficiencies and the light environment that you've hit on a couple times. So before we go into the minerals, can you throw out a couple of things that we are doing kind of in a daily basis that throw off that light environment for ourselves? I'm sure you're a huge fan of wearing sunglasses. I have a feeling, but can you go into what are we doing that is hurting that cycle?
Yeah, sure. So I think we need to be aware of the fact that the mitochondria are continually trying to understand what time of day it is. Every cell in the body and various aspects of the cells are trying to understand what time of day it is. And based on the time of day, those mitochondria in particular know, oh, it's the start of the day. So Carrie needs more energy produced in her thyroid, her digestive organs, her reproductive organs, and her adrenal glands might need to produce more cortisol, right? They can partition which parts of the body need to kind of turn on when. And so the way that we tell time of day is through the amount and intensity of blue light in our environment, which was the perfect wavelength to tell time. Because if I was living the way a wild human should be living, is I would be outside, I would have slept in an environment that was likely lit by campfire, and I would be exposed to natural light all the time. And as soon as the sun breaks the horizon at sunrise, all of a sudden, that's a signal. I have got the amount of blue light coming to me from the sun matches the amount of red light. So it's a signal that essentially starts daytime in the clock in my brain. I've got these little sensors in the backs of my eyes called melanopsin receptors, and their job is basically to start firing off and communicate to the clock in my brain called my suprachiasmatic nucleus. There's essentially, as they fire off, they're helping my brain interpret time of day. So they'll fire off. There'll be less blue light at sunrise, and that blue light will gradually increase in amount and intensity until solar noon, when the sun's at the high point of the sky. And then it'll gradually decrease until after sunset and then darkness, there's no blue light in a natural environment. So my eyes would be essentially saying a little more, a little more, a little more, lots, 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 less, which was perfect because it is the one wavelength that varies predictably just like that from sunrise to sunset. And I'll call it not just one wavelength, but wavelength range of light in the blue spectrum right there. Now, what did we do approximately 20 years ago? We made all of our lighting environments, we made them LED based. And LED light bulbs have a very dominant spike of blue, and very little to no red, and definitely no near infrared light. So none of the other wavelengths of sunlight that are very beneficial. And so the average human, just by living what we would consider a normal life, will be subjecting themselves to circadian rhythm dysfunction and thereby confusing their mitochondria and driving the mitochondria into dysfunction, which we can talk specifically about those mechanisms if you want. But let's say I wake up and it's before sunrise. I wake up, I look at my phone first thing. That's what the average person does, right? We look at our phone and we want to know what time of day it is. I can hang out in bed for 20 more minutes. Let me check my emails. Let me check social media. But what we're doing is we're injecting an aggressive amount of blue light into the eyes first thing in the morning, when that amount and intensity of blue light wouldn't be something we would have received until later in the morning, if not towards the lunchtime, afternoon hours. And so that alone, all of a sudden, is like I went from sleep, now all of a sudden it's the middle of the afternoon, and the body is trying to kind of interpret and play catch up. Like, okay, what organs need to be active now? Where do the mitochondria need to be firing more or less? And then the day kind of just gets worse from there typically, because the average person doesn't mind their LED exposure from screens and bulbs while we're getting ready for work or while we're making lunch for our kids, all the things. And then the one time when we have access to natural light, and as we're driving to work, it's typically windows rolled up or sunroof closed and sunglasses on. And so the moment that we had to maybe sync back up to the blend of light that would signal time of day is the time that we really confuse that with things like sunglasses. And then, in an office environment, again, kind of under this chaotic signaling, we go home, we wear our sunglasses, we're behind closed glass, both of which are not the same as being in full spectrum light. And then, come home and flip out all the lights to get everything that we want to accomplish into the evening, watch the TV, maybe scroll on our phone before bed, and we rinse and repeat that same cycle day in and day out. And over the course of time, it creates a big issue with timing and circadian signaling that can start to inhibit mitochondria. You can literally shine blue dominant light on mitochondria, and they start to inhibit their ability to flow electrons and make water and ATP. And there's at a certain point in time, there's a threshold that's reached of those dysfunctional mitochondria in a given tissue. And now we have symptoms or we have a disease diagnosis. And a lot of it has to do with just this lack of awareness of our light environment.
How have you been able to share with your followings, your client, the importance of that? Because this seems so innocent, right? This is something that we all do. It seems very innocent. It's just light, right? It's just light. How have you been able to say that this really is fundamental?
It depends on who I'm working with, right? I've got some clients who have tried everything, every functional lab, all the different diets that they thought would be beneficial, every supplement protocol. And so now they're willing to listen to something that might sound a little out there. And I find that clients who give a couple of key strategies a try have very repeatable results that I had, within 3 days, there are noticeable shifts, enough that they start to say, okay, this is something that really is moving the needle. I want to continue. And I've not had one person who started to pay attention to when they block artificial light versus when they want to get natural light exposures. I've not had one person who kind of optimized that and started to feel better say, nah, that sucks. I want to go back to what I was doing before. It's I'm not one, right? And so that shows you that it's almost like reconnecting us to a natural human habitat that our body instinctively was craving that we didn't even know we needed. And so that right there is huge. But then I've got skeptics who are just like you said, you're telling me that light really matters. It's like, what? And that's where you start to break out the hundreds of studies on circadian rhythm dysfunction and how circadian rhythm dysfunction is being tied to every diagnosed disease we have these days. Cancer, Alzheimer's, diabetes, all forms of metabolic syndrome, autoimmunity. And so that starts to get people to listen. And then if you need people who need even more mechanistic than that, then you're like, this study showed someone shining a blue flashlight on mitochondria and it hurt the mitochondria, right? I mean, so you can start to layer it on depending on the type of evidence someone needs. But again, the practical applications of this start to speak for themselves. You have someone who had insomnia and now they don't. You had someone with low energy and now they don't. Someone with severe digestive pains and now they don't. It's very rewarding because I finally feel like as a clinician in my toolbox, I now have the tools that are foundational to help people really, truly start to improve their health.
Wonderful. All right. So let's tie in the whole mitochondrial aspect again. The mitochondria does a little bit more than just produce ATP, doesn't it? Like it does a lot. And I don't know that we really have even scratched the surface on understanding. So a couple things that really stick out to me that you never really hear about is that mitochondria produces water, metabolic water. It's fascinating, right? CO2, light, energy, right? Outside of the ATP. I think that's really, really, really important to realize. And so we're not just optimizing ATP production when we're doing these things to benefit the mitochondria. So can you tie in the addressing minerals for mitochondrial function and how you go about that? How, for example, Morley Robbins is a dear friend. Morley's laid out how copper is so important and then how we are extremely deficient copper, but we're also told by the medical industry that it's toxic, right? So we've got all these things going on there. So how do you tie in this mineral deficiency epidemic that we have? How do you address that and educate around it?
Well, number one, if I do suspect people have copper issues or, a lack of ceruloplasmin, for example, I direct them 100% to Morley or people who are proficient in that type of root cause protocol approach. I feel like let me speak to copper in particular, just to the mitochondria, because Morley is spot on with that. Through my lens of, I believe that water production in the mitochondria and mitochondrial infrared production is equally important to ATP, if not more so. And the specific cytochrome that makes the water, cytochrome C oxidase or cytochrome 4, has 4 copper sites essentially, right? And each of those copper sites harvests a different wavelength of red or near infrared light. So it's a combination, just like you said. If we don't have the copper in the first place that's able to be in the correct sites, we're not going to be able to harvest the light. If we don't have the light exposure that has the correct wavelengths of light, we could have the copper there, but again, we're not going to receive those wavelengths of light because that copper isn't being exposed to it. So they go hand in hand. So for people, I have had many people go through something like a root cause protocol and have benefits. With my clients, I start the baseline that I start them off with, because you hit the nail on the head, they are very mineral deficient. But what I start them off with is where we're talking people who are already eating clean, they're not eating trash foods. They understand these concepts, but I don't have them typically start off in any capacity with mineral supplementation of single minerals. I start with more of a broad spectrum mineral supplementation, and I say that they need ocean-based and they need earth-based. And this has been a fun strategy to hone in on. The ocean-based mineral that I use most frequently is called Quinton isotonic. It is a C plasma, right? So I don't know if you've had Robert Slovak on at all, but it's a C plasma. that has the same mineral concentration and blend as the blood, the interstitial fluid, which is the fluid that surrounds the cells, and the cerebrospinal fluid. And so that's Earth's internal oceans. Essentially, the waterways of the body is the oceans. Then we've got land masses in the body. And for those, I have clients take an earth-based supplement, again, full spectrum supplement, something that has a fulvic and humic acid component to it. There's different options out there. And so that I find that preferentially actually has an affinity for the intracellular environment. And so this is just through clinical observation, where I noticed that when people consume the Quinton isotonic, they shut off a dehydration signal through the blood, which can really be trigger histamine reactions. So I've seen histamine reactions literally stop, and some severe aggressive ones, when you have correct hydration and mineralization of the blood. When you have correct hydration and mineralization of the blood, then the capillaries can leak plasma and minerals into the interstitial fluid to bathe the space around the cell, to clear any wastes through the lymphatic system, or to clear wastes through the blood, like essentially eliminate carbon dioxide, things like that. So that's a very key thing to address right there. But I found that when I was looking to support intracellular mineral status, like what's happening with people's energy levels, which is typically indicative of how their how their mitochondria are making ATP in water. I found the needle moved drastically more when I added in an earth-based mineral. So I've got this hypothesis now that our interior cells, the intracellular environment, that's land masses, the space around it, and the rivers that flow are ocean-based. And the combination of both can move the needle a ton as a general initial remineralization strategy. And then from there, we start to sort out like what other mineral deficiencies are appearing now that we have those two areas covered.
That is a fascinating way of doing it. That's fascinating. Yeah. So, Caroline Allen, another friend, she has Beam Minerals, and so we've gone down the whole rabbit trail of humic and fulvic complexes, and it's just absolutely fascinating, especially when you throw in the humic detoxing capabilities. I think that's also really cool. But I love how you just divided it up like almost like a whole holistic natural way. That is, I've never heard it like that. So thank you.
You're welcome. Yeah, and it's just kind of as I've been blessed to observe enough clients, and it's like it makes sense that the earth kind of has ocean minerals and land minerals, right? We are just kind of microcosms of that, and we have the same requirements.
I love it. All right, a next one that I want to get your take on. So the first time that Jack Cruz was on, I went instantly from him having my mind just completely blown and went straight to Morley for the first time. Like no break, like the end, go straight into Morley. So I'm trying to process all this, right? And then be prepared for Morley and act like I'm not just some country guy on the side of the road. And so as we're going that, I couldn't help but just have to ask him some of the things Jack brought up. And so when we were discussing melanin, Morley came in with this whole copper connection, from the PAM enzyme, the tyranase, and just all the way through how melanin was produced. So as I kept going into that, because one thing Jack told me was for my son, the number one thing I needed to do, because he was stage 4 kidney cancer, is he needed a tan on his back and basically avoid devices. And I'm thinking, what does a tan have to do with cancer, right? Like this is craziness. So the melanin story is fascinating. It's incredible. I don't think we talk about it enough. So with all that said, how do you educate on melanin? What are your thoughts around melanin? And is that a part of your protocol? If you try to encourage people to get a tan, what are your thoughts?
Oh, absolutely. There's 3 ways I actually try to optimize melanin in people. The first one is through getting a tan. And so let's lay the foundation. This is also where it's paradigm shifting. Again, this extends beyond food, because the assumption is that the only places that the only way we can get energy for the human body is through eating food. And that is absolutely not the case at all. And in fact, the main melanin researcher, Arturo Solis Herrera, he hypothesizes that in some tissues, up to 90% of its energy is not through the electron breakdown of food in the mitochondria, but through melanin creating energy and oxygen for the tissue as well. So how does melanin do that? Well, melanin is this pigment, and melanin's a molecule. All molecules in the body are surrounded by what is called a hydration shell of water. So it's structured water around the cell. This hydration shell of water can serve different purposes. It's also why I think a lot of biochemistry research, this isn't just a deviation, a lot of biochemistry research, I don't think we can take at face value because they completely ignored water. Right? They assumed water was there, but not an active participant. And now we know that biomolecules will never touch each other. There will always be the energy exchange through water. So we have to completely revamp our biochemistry research. But that being said, I find that with melanin, the most fascinating thing about it is that melanin generates energy in the form of something called creating molecular hydrogen. How does it do that? Well, melanin's pigmented, and things that have pigments absorb wavelengths, lots of wavelengths of light. And melanin, it turns out, can absorb all wavelengths of light. And so what melanin does is it absorbs light. And as it absorbs light, the hydration shell of water around it, it causes two water molecules to split and generate molecular hydrogen and molecular oxygen. That molecular hydrogen, what is hydrogen? It's an electron holder, right? It's an electron carrier. And so then those electrons can then get donated to various redox reactions in a local tissue. The molecular hydrogen itself is a gas that can diffuse. There's a high bioavailability of that gas diffusing. For example, we now know that molecular hydrogen, this is through consuming hydrogen-rich water or inhalation, for example, but it will increase mitochondrial membrane potential. So we know that we can essentially do things that generate molecular hydrogen and help the mitochondria optimize their production of water and ATP. And so this is where the melanin story comes into play, because it literally is capturing energy from sunlight and doing this beautiful process that just happens spontaneously anytime our melanated skin is being exposed to light frequencies. I also think it's why, and again, I'm always interested in my demographics, my populate, like who am I working with? And I oftentimes see melanin will also absorb non-native EMFs. And I find that of all the people that I work with, the vast majority of people who are hypersensitive to non-native EMFs have very little melanin pigmentation in their skin. Whereas those who have higher and higher melanin pigmentation are not sensitive to non-native EMFs. And my wonder are these people absorbing the energy from the non-native EMFs and simply using it, melanin using it to split water and actually using it as a source of energy? So I think this is something that we don't look at. And I'm all about optimizing the many ways in which the body will derive itself from energy, and certainly getting a healthy sunlight exposure. As we're getting that sunlight exposure built up, we're getting circadian signaling if we're not wearing sunglasses. And as we build more and more of that melanin, we're allowing the body to have more of this pigment, this rich pigment that can help us then split water and generate molecular hydrogen, again, to fuel the mitochondria. So it's something that, of course, evolution, or however you want, people argue about this. So it's of course something that we've been given to optimize human health, and it's something that we've been taught to fear, and I think it's to our detriment.
No, it's mass chaos. It's insanity chaos. That we've been convinced that the sun is killing us. It's like absolutely crucial. But to your point on a couple of things on the melanin, I have noticed, and this is even with like my own kids, like different tissues have a different degree of melanin, right? Like sometimes the face is very pale. And so like one thing that I emphasize on my son, the Lander, the one that had cancer, is like his face stays pale than the rest of his body. So I am having him in the sun, laying out, looking at the sun all the time, because I think you're spot on with it's doing something, right? Whether it's internally, we're pulling in the melanin or melanocytes or whatever, being exposed to something where it's getting disrupted. Maybe, Jack says that melanin will break down into dopamine, right? Through blue light. It's really fascinating when you start paying attention to these little things, whereas his little back is about as tan as it can get. So just constantly trying to pay attention to that. And then are we having the appropriate minerals to have all of the enzymatic functions? Are we doing all the things that we need to do? So with that, Carrie, Who are you seeing have the biggest jump in being able to build melanin? Are there certain things that are we can do to really help with the tan? And before you answer, let me interject one more thing. Petra started playing around with chaga, and so I've started adding chaga to like coffee. Like I am a coffee addict, but I put chaga in there, and I've noticed I don't lose a tan very easily. Like it takes a lot to be able to lose a tan, and I know that like fungal melanin is not going to be exactly the same, and I'm sure that human melanin is way more important. But what are you seeing for the ability to gain or retain melanin?
Yeah. So number one, there's actually research that consuming melanin can help the body maintain melanin stores internally. And so that's the name of the game is I think our ability to maintain a tan is indicative of how well we're maintaining internal melanin stores. So we can go into why might people might lose a tan, let's say in the winter, or some people actually keep a tan all winter long. And we can talk about why that could be. But that being said, how does someone actually start to build melanin? Well, I was one of those people who assumed that I just burn, right? I got that Fitzpatrick skin type. I'll never tan. I'll just burn, which was my experience up until, about 13 years ago. And I realized that I was misusing the sun and wasn't building this adaptation. And what I was doing was typical Michigan. This is a typical Michigan story is I was staying inside up until Memorial Weekend. And, finally it's the first really quote unquote nice weekend of the summer. And I'm going to go outside and we're just going to go to the beach and I'm just going to ultimately end up frying myself because I would go to the beach all day and wear sunglasses and I would come home and then I would get so mad at myself because it's like, I told you the sun was bad for you and I told you it was out to get you. And I was just misusing it. I literally, ever since I flipped the switch on that, I started slowly building my solar adaptation from March onward without sunglasses on. And now I can't burn if I try. And so part of the reasons why people can't get a tan is because they're not giving their body that chance to slowly build melanin in their skin in response to the gradual increase in UV exposure from spring onward. And they're just giving themselves these intermittent exposures that was creating a massive amount of inflammatory reactive oxygen species in my skin. That wasn't an ideal situation for me to be in. However, now I can be at the beach all day because I've been able to teach my body how to put on melanin and layer on melanin and other endogenous skin protection factors that my cells make in a way that I can, middle of August, be at our family lake house for 3 weeks and never have to, I would never do this anyways, but never have to think about putting on sunscreen because my skin now can adapt that much quicker. Now, again, like you said, mineral status plays a role as well. Some people may not be making those minerals because they don't actually have an active tyrosinase enzyme. So as Morley was saying, that's copper dependent. There's a lot of mineral components to these enzymes that can make melanin being able to be active in the first place. So perhaps that's at play with some people. But the vast majority of people I see, they're either just not exposing themselves to the sun because they're afraid of it, or anytime they do expose themselves to the sun, it's like my experience. Memorial Weekend, 4th of July barbecue, here and there. And every time I did, I would just overdo it because I had never seen the sun for decades. And all of a sudden I was expecting my body to adapt and I just didn't give it that adaptation phase.
Yeah. It just kind of makes so much sense. Really, I think I'm still on the minerals, the ocean and land minerals. I think that is so fascinating and I can't wait to fully be able to process that. You mentioned Michigan, and another thing that it took me a long time, Carrie, to embrace this, but cold therapy, cold thermogenesis. How do you view that? Where are you on that realm of creating a protocol and sticking to it or not? Why is cold important, and is that something that you utilize?
Totally. I utilize it for myself. I utilize it for the vast majority of my clients. I've got a whole, 15-day challenge that I call the Prep for Winter Challenge that literally teaches people how to get cold and why getting cold in preparation for winter is beneficial. So in terms of this whole melanin story, when we expose ourselves to cold, we actually make ultraviolet light inside of us. Our cells start to release more UV light. I'm sure Jack has said that before. And that then helps our internal melanin stores stay pigmented. And so that's why there's people like my lovely colleague, Sarah Pugh, in the 55th latitude in the UK, who is staying insanely tan all winter long because she has a really profound cold plunging routine that she goes through to maintain that. The other aspect of cold and mitochondrial health, so beyond the melanin story, is that when we get cold, and now when I say we, I do want to make note that we have some different types of mitochondria. There's different mitochondrial haplotypes or haplogroups. Essentially, where did your mom's and her mom's and mom's mitochondria originate from? And if those mitochondria originated away from the equator, they would have expected a season of cold. And those mitochondria that experienced cold seasonally would have to learn how to help the body generate more body heat. And the way that mitochondria that can do that, they do something called uncoupling. And what that means is they temporarily stop the flow of electrons and protons through cytochrome C oxidase and the ATPase and open up a channel in the mitochondria membrane called uncoupling protein. And when they open that channel, and when protons, that essentially allows those protons in the inner membrane space of the mitochondria to flow aggressively into the interior of the mitochondria. And wherever protons flow, heat is generated. And so some people have mitochondria that are very efficient at that. The vast majority of people, though, have not trained it enough to have that effect, to have those mitochondria efficient at opening that pore. And this is a concept that I coach for people called activating your brown adipose tissue, because there's a type of fat tissue that is actually not like the pinchable fat that we think of when we think of fat, but it's fat that is located above the clavicles, tops of the shoulders, between the shoulder blades, that's very dense in mitochondria. And that type of fat is designed to sense cold. And when they sense cold, it's those mitochondria there are designed to uncouple and make heat. And originally, we thought that capability lay dormant in adults. I remember maybe 15 years ago now reading a research article about a mortician in South America who had a baby that was born, and supposedly that baby passed away at birth. And this baby was then put in a deep freezer overnight because the mortician didn't have time to take care of it and prep it for a funeral. And when he went back into his office in the morning, he heard cries coming from this cryopreservation area. And it was the baby. This baby was alive. And this baby had been able to generate its own heat enough to sustain those freezing temperatures, or at least those very, very cold temperatures. And turns out that kind of opened up this door of how did this baby do this? And it led to a boom in research on brown adipose tissue. And the original research said, oh, babies have a lot of brown adipose tissue because they can't shiver. Their muscles can't control themselves to shiver. They can't put on a sweater. They can't change the thermostat. So they must have a lot of mitochondria and a lot of brown adipose tissue that can make heat for them, and so that they can thermoregulate accordingly. But they were doing scans of adults, and they were saying, but it looks like the scans of babies, you can essentially do a scan where you can visualize more dark areas where there's this brown adipose tissue. Yeah, babies have it, kids have it. Oh, nope, adults, they don't have it anymore. Adults must just lose it. Turns out that if you live in thermoneutral conditions long enough, those mitochondria stop becoming active. And so you have to coach that response back in. So living in Michigan, I used to hate the cold because the only means that I had of heating myself up was shivering. If your mitochondria cannot create heat for you, literally vibrating your muscles is the only means you have to generate body heat. So I would go outside. I would be out there for 10 minutes. I'm like, oh, this is miserable. I'm freezing. My teeth are chattering. I can't. And so it was like, oh, I'm just not a winter person. Well, no, I had been living in a thermoneutral condition. So as soon as I started once my strategy was, well, now that it's a little cooler in the fall, let me just go outside like I normally would. Long sleeve shirt, maybe, shorts. Let me do my walk like I normally do and just see. And I just began adapting like that, and occasionally maybe putting on a little bit heavier of a layer. But compared to what other people were wearing, I looked naked. on my walks compared to, the big parkas and, the wool hats and the boots and things. And it turns out that if you just slowly and gradually expose yourself even to the ambient air, those mitochondria start to feel the cold and become active again. So even if the idea of a cold plunge right now for people listening sounds awful, which it did for me at first, you can use the air temperature alone to start to adapt. Even my mom, I was like, Mom, just go outside in the morning, get your sunrise eyes, sync your circadian rhythm, and just go out in your pajamas. Don't put any clothes on in the as it gets to winter, and she's like, wow, I find I kept myself warm all winter long. It's like, I know, Mom, you can do it, right? And so this is a strategy that people can use, and she would never cold plunge. But then if you want to kind of take it to the next level, because there are some major benefits that you can get from strategic cold plunging. But there's, of course, this idea of getting into a cold plunge, and there's you do it for a shorter duration because the heat escape from the skin is way more aggressive when you're surrounded by cold water than cold air. And so I teach strategies on that as well, and there can be some massive benefits for that in terms of maintaining internal melanin reserves too. So yeah, I think cold is something that can really go a long way towards our body heating up. And it's not only heating our bodies up, but when we can generate that internal heat, which is also known as internal infrared, then we structure the water inside of our bodies and inside of our mitochondria. And that structured water helps the mitochondria maintain electron flow because it's excited water. It's negatively charged water. So the electron flow through the mitochondria becomes optimized. So this is where a relationship with the cold allows us to generate infrared that essentially benefits the mitochondria and what I would call this internal water battery that we also have.
It's all connected. It's all connected. It's just, I'm just in awe. The more we learn, the more we apply on just the entire design. It's absolutely incredible. So, Carrie, tell us where we can learn so much more about all the amazing stuff you're doing, and where we can follow along with what you do.
Yeah, well, thanks so much for having me, Logan. My hub of where I just like to put out this stuff in bite-sized chunks is on Instagram. So you can follow me on Instagram. It's Carrie B Wellness. You can also go to carriebwellness.com, and I've got courses for individuals and practitioners if you're interested in learning more about this, and basically completely reframing how you view the body through what I call this quantum lens. And it's been so rewarding, not only for me, but for the feedback I've been getting from people. So it's been fun.
I love it. Well, thank you so much.
Thanks for having me, Logan.
Thank you for joining us in the Sowing Prosperity mission. If you like this content, like and subscribe, share with your friends. Be sure to check out sowingprosperity.com. Sign up for the email. We've got so much more work to do.